This is the informal definition of a limit. So here's your graph of f of x.
What's your test?
And let's say we want to know what the limit is as x is approaching a. So as x is approaching a from the left, it is approaching this value L1. And as x is approaching a from the right, it is approaching a value L2. Now if L1 equals L2, then the limit exists and it equals f of a. So there are some functions, as stupid as that looks, there are some functions where this doesn't work. So here is a function that has no value at a. So as I sneak up on the right, I'm sneaking up to this guy. I said from the left actually. If I sneak up from the right, it is sneaking up to the same guy. So notice that the limit could exist even if the point doesn't exist.
So it's like 3 years.
So what if they don't equal each other? For example, this guy right there. As I sneak up to A from the left, I get an L1. If I sneak up to A from the right, I get an L2. But L1 does not equal L2, so the limit does not exist.
If the limit never approaches anything, the limit does not exist. The limit does not exist!
So the limit can exist if the point exists, the limit could exist if the point doesn't exist, and it's possible that the limit does not exist at all. The informal definition of the limit is the limit as x approaches a of f of x equals L if and only if. 1, the limit as x approaches a from the left of f of x equals L1. 2, the limit as x approaches a from the right of f of x equals L2. And 3, L1 equals L2. Those are the 3 conditions for a limit to exist. That's an informal definition limit. Formal definition limit involves delta epsilon proofs. Okay, this is number 7, and it says, what is the limit as x approaches 6 of f of x, where f of x equals x plus 6? So I'm going to do this by a picture. Here's the function x plus 6, and there's 6, there's x-axis, there's y-axis. If I come out here to 6, then that point right there is 12, because if I were to plug in 6, I get 6 plus 6 is 12. Now, the limit as we approach 6 from the left causes this guy to approach 12. So the limit as x approaches 6 from the left of f of x equals 12. That's 1. Let's look at 2. The limit as x approaches 6 from the right of f of x. Well, I'm coming down this way towards 6, and the closer the x gets to 6, the closer this guy gets to 12. So it is also 12. And then step 3, 12 equals 12. So the limit exists, and it equals 12. Okay, this is how to derive the derivative. So the derivative is going to be the slope of a function at a particular point. So if that's a, that's f of x, and that's f of a. And we want to know the slope of that guy right there. So if I take a cajillion power microscope and look right there, then it looks like that. If I put a cajillion power microscope on my cajillion power microscope, look right there, it looks like that. If I keep doing that, we can see that that guy gets more and more and more and more linear. And the slope of this would be the change in y divided by the change in x. Our slope would be delta y over delta x. But if I make that smaller, 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 and let that get smaller forever, it converts into a dy dx, which we call y prime the derivative. So we are going to take the limit as this guy gets closer and closer and closer. So we will have f of x, some point x, and f of x. We're going to come over to x plus h, which means we have a distance of h. which will bring us up to f of x plus h. So the slope of that line right there is slope equals, we'll call that the derivative, which could be y prime or f prime of x. And it will equal the limit as that h gets smaller and smaller and smaller forever and ever and ever of the change in y, which is f of x plus h minus f of x, all over the change in x, which is just h. So right there is the derivative of f of x.